Do you want features that look like this or like this? In the last video, I challenged you to think about what statistical test we might run to take our data set of 2,000 features to figure out what is the single most informative feature of our NIR data. So when you have instruments like this that can collect a lot of data, this device can collect 2,000 variables on a sample in a matter of seconds. And if you imagine we may have a study with 50 samples, we might need a way to figure out what is the noise and what are the useful features for building a model, particularly when we don't have a lot of data. And so I showed you in the last video how we can build an interactive widget for moving through this data. You can see just by sliding this, we can look at all of the variables as it relates to our various clusters. And this particular data is on coffee and several different adulterants and how we might be able to begin predicting whether we have authentic coffee or one of the adulterants. And here you can see some of the features overlap depending on the wavelength, and other wavelengths, the features are quite separate from one another. And so again, I ask you, do you want features that look like this or like this? And this is the exact type of question that the F-test really helps us to get at. And so I will show you a single test that is really useful for figuring out features that are really important, particularly for classification tasks or tasks where you're trying to separate based on some identifier. So I've got my NIR data, and in this case, I'm just figuring out what are my wavelengths. So let me show you what this data frame looks like. I've got this cluster NIR data. Look at the first 5 rows, you see that I have my cluster ID. So I've done k-means clustering. And here I've got several different wavelengths. This could be M over Z, this could be retention time, this could be ppm shifts, depending on what type of instrument you've got. And I have some identifier information here. In this case, like I said, is my clusters from my k-means, but these really could be classifications that you've input from your samples, and we'll be doing that in future videos. So subscribe if you want to see this journey as I move through this project. And so what I'm doing is generating my list of wavelengths. So I am skipping the 0th column and moving here. And then I'm going to create a dictionary to hold my F stats. And essentially what the F test is a measure of the between group variance over the within group variance. And the idea is we're really trying to maximize this F score, this F value, by looking for variables that really within a particular sample class are very tight and have a very small variation. And then between classes is very large and are very different between class A and class B, or class B and class C for the number of classes we have in our study. And so over the course of this for loop, I'm going to loop through each wavelength and then perform the F test over the different groups. And these groups, again, are based on my k-means clustering groups. And then I'm going to store that in a dictionary. And at the end, I'm going to figure out what is the best wavelength by figuring out which wavelength has the largest F stat. And so we can see that the feature at 1730 is the most important feature. So one way to visualize this is by looking at how much the data varies over the course of the experiment. And so now I'm plotting the average spectra, but I'm also showing the error bands for each of these wavelengths for each of our clusters. If you can see around 1730, the samples are really tight. So although visually there might look like there's some other regions that are more informative, because the variation, particularly for cluster 2 in green, is so wide, it makes it really hard for the model to be confident in the context of the F-test, whereas around wavelength 1730, we have pretty good separation between our classes, and importantly, we have very little variation within the class. So we're seeing where we have really reliable measurements, and thus the single most important wavelength is 1730 nanometers for this study. But you can imagine we don't have to take just one. We could extend this to the top 10, the top 50, even the top 100, and that might really help our models perform really well versus taking all the data. Of course, we can use PCA, and there's even other types of tests we can use to get at the same type of information. In any case, I hope you enjoyed the video, and I'll see you in the next one. Peace.